Hello, I'm Noah Rosenfield, and today I'm going to be demoing the results of our automated blueprint room finder. When you have blueprints and you need to be annotating them to find the actual rooms, it's a very time-consuming manual process. So we're using computer vision to try to, we're doing a couple of things. We're using machine learning and computer vision along with some geometric algorithmic approaches to try to automate this process. Now, I was hoping to be able to show this to our deployed app, but we're running into some AWS deployment issues, so we're going to have to just show what we were able to do locally. So when we started out with a machine learning model that was trained on the Cubicasa 5K dataset. A friend of ours who's working on the same project, Marcus, he trained this model and it was available in AWS for us, and he was happy to share it. So we decided to take this model and see what we could do with it. So with our original blueprint, just found off of Google Images here down on the left, we took this and a few others, but this was the one that gave us the most interesting results to work with so far. So we processed this blueprint through the machine, through the YOLO model that's been trained on this, annotated data set of blueprints with their actual walls and there's two actually. There's the walls and there's the rooms. So we went with the walls first. And so what we do is we process it. We get back the JSON for that, for what the model thinks are the wall annotations. Then we draw those walls over the top of the original blueprint and make a copy of the image. And that's what you're seeing here. This one is with a 15% threshold. And actually, usually you want the thresholds higher, right? Because you don't want it to hallucinate too many of these things. But actually, in our case, the way that we're doing this, we've dropped the threshold down to be lower, and we're actually allowing it to hallucinate some things such that it draws over more of our blank spaces like doors and windows. You can see in the top image, this door does not get drawn across. It doesn't recognize that this is actually going to be a closed space, whereas our 10.1 threshold does a little more drawing across this space. So what we do from here is we're then able to use a combination of regular computer vision and a geometric algorithmic approach. So we can see on the top left here, this is, I believe, just Claude Vision taking in that, the image with the walls and spitting out what it thinks here. Then the middle image is what it was getting to process, along with the JSON annotations. Then the right one here, this one is the original. Got the original blueprint, the updated blueprint, and the wall annotations. And you can see they're pretty similar. I don't know. It decided to draw this a little bit differently, but they actually look like, to me, it placed the labels a little differently also, but mostly they're the same. However, what was really interesting is once we added in the geometric algorithmic approach, what we're getting here now, instead of just a room bounding box, we're actually getting a merged white space with the vertices for this room. So this was a lot more interesting because it's able to actually handle some pretty complex shapes here. You can see we're still having an issue over here where, since the little bit of wall piece here wasn't merged in, it actually thinks that this bottom right room is part of room number 3, this large complex room. So we still have some work left to do to try to sort this out and make it a little neater. But so far it's been really interesting to see what we're able to do, and I really like this vertices approach. I think it will allow us to do some really good annotations of complex shapes. So hopefully for the next video, we will have our AWS deployment working, and we'll be able to give you the deployed app. Thanks for watching.